In this video, we'll review some fundamental math symbols and concepts that we'll be using in future videos. As we start to calculate some descriptive statistics, there are a few basic mathematical symbols and concepts that you'll need to be able to properly interpret and use in order to calculate things correctly. To learn these, let's start with some simple data. We'll say that we have the following 7 quiz scores for 7 students. We can use X as a way of generically talking about this data with a subscript after the X to indicate the score for a specific individual we're talking about. So X sub 1 is the score on X for the first person, which we see is equal to 2. And X sub 6 is the score on X for the 6th person, which we see is equal to 8. We use I as the subscript to more ambiguously refer to some person in the sample rather than a specific case. So X sub I is another way of saying the score on X for person I. Now, the Greek letter sigma is a mathematical way of indicating summation. It's a way of saying add up the following values. You may see it written with I equals something immediately below the sigma sign and some numeric value or symbol immediately above the sigma sign. This just tells you which specific cases to add up. In this example, we're adding up values for X sub I ranging from I equals 1, or the first case, to I equals 7, the 7th case. You may describe this as the sum of X sub I with I ranging from 1 to 7. Let's actually solve this to see what we get. Here we've written it all out and see that the sum of X sub I when I ranges from 1 to 7 is equal to 2 plus 10 plus 8 plus 3 plus 6 plus 8 plus 5, or 42. Okay, pretty straightforward, right? Now, there are other ways that you may see this summation sign that are basically the same thing, only slightly tweaked. For example, you may see the I equals 1 and the number 7 next to the sigma sign instead of below and above it. But this is saying exactly the same thing. Or instead of seeing a number on top, you might see the letter N. This is just a more generic way of saying add them all up without worrying about how many there are. Later on, you may see other letters on top like J or K, where those letters refer to some other specific value, such as how many different groups there are in our sample. You may just see the summation sign with nothing indicating the range to add up. No I equals or number or N or anything. This is just another way of saying add them all up. Okay? Let's go through a couple examples for practice. What is this equation asking you to do? See if you can describe it mathematically in the way I did a few slides ago before calculating a value. Okay? Pause the video and give it a try. In English, this is asking for the sum of X sub I where I ranges from 2 to 5. It's equal to 10 plus 8 plus 3 plus 6, or 27 total. This is a little trickier. First, think about exactly what this is asking for and how you might describe it in English, and then calculate the value. Pause the video again while you give it a try. The key here is that xi plus 2 appears in parentheses. So you first have to calculate xi plus 2 for each of the values of x ranging from x sub 4 to x sub 6, and then add them up. So it's 3 plus 2 plus 6 plus 2 plus 8 plus 2, or 23 total. In English, you might describe this as the sum of the quantity xi plus 2 with I ranging from 4 to 6. Now, notice how this equation differs from this one. What's the difference and what would be the impact on both how you describe the equation and what the value is? Pause again and give it a try. In this case, xi plus 2 is not nested together in parentheses. The plus 2 is outside of the summation part of the equation. So think back to order of operations, and we will first do all of those summations, and then at the end we add 2 to the value. So we add up the values of x sub 4, x sub 5, and x sub 6. That's 3 plus 6 plus 8. And then we add 2 more. We're not adding 2 to each of the values of x sub I because it's not nested within parentheses in the summation sign. Again, it's outside the summation part of the equation, so we just add it at the end. One last one. What if x is a constant? Everyone has exactly the same value. Let's say 2. Nothing really changes, but there is a pattern that's worth noting. Instead of going through the process of adding 2 plus 2 plus 2 plus 2 and on and on and on, you can just calculate whatever the value for n is times whatever the value of the constant is. In this case, the answer is just 7 times 2, or 14. You might see this written as the sum of x sub I when I ranges from 1 to n is equal to n times x if x is a constant. Okay? I hope you found this helpful. Being able to recognize and correctly use the summation sign and the notation of x sub I is going to be important as we go forward, assuming you want to calculate things correctly. Okay? Take care. Bye-bye.